Alright, problem set 7. I'm trying to do this a little different. You can see, trying everything with the software.
What's the name of this one? The app?
Docere. D-O-C-E.
That's just what it's called?
Yeah. Alright, problem 1. The resistance is given as 9.6 ohms. The voltage is 240 volts. You're asked to find the charge, isn't it? Mm-hmm. Passing in 50 minutes, you know, cannot be in minutes. It has to be changed into seconds. That's 3,000 seconds. According to Ohm's law, current is voltage by resistance. I is 240 divided by 9.6, which gives you 25 amps.
That's the current.
That's the current. I want to know whether it's too fast.
No, it's good. It's good. It's good.
Trying to save time. Because I have to do this work before to be able to save time here. You see that? Yes. That's what I'm trying to do. Okay. And then I is again Q by T. Isn't it? Current is the rate of flow of charge. So you got your current, plug it in. Rearrange. Charge is current multiplied by time. Current is 25. Time is 3,000. And therefore you get 75,000 coulombs. That's the answer to number 1. And I just want to know how many people got that. That's the easiest, straightforward question. Okay. Now, second question. Change in temperature causes a change in resistance, isn't it? And the formula that's given is RT is RO 1 plus alpha T minus T naught. You know alpha is a constant called the temperature coefficient of resistance. And so I'm rearranging. What I did is I divided by RO, took -1 to the other side. You can do it either way you like, but you know. Okay. And then divide by alpha, you will get T minus TO. That's the change in temperature. And then I put 140 divided by 12 minus 1 by 0.006. And you should get 1,777.8 degrees Celsius, which is what I got. Anybody got that?
1797. I got close.
If it's close, it's okay.
179. I don't think mine's close enough.
Okay, that's not the final answer because I wasn't sure. Okay, how many got that?
I got
One. Because remember that was just the change, isn't it? Yeah. And to find, I had to add 20 to that. Okay. That's good. How many have done number 3? All right, so I think I can go into number 3 too. All right, after number 3, you'll get more time. Resistance is rho L divided by A. Rho is the specific resistance or resistivity. And I'm giving A as aluminum and C as copper. Okay. Subscript. So RA by RC will turn out to be that. Is that right?
I saw them separately, but I'm sure.
Because when you divide, you flip the second one and multiply. That's what I've done.
Yes.
Okay. And therefore, RA by RC, because I was too lazy to look at the resistivities, so I just kept it as it is. And then area of cross-section is pi r squared, isn't it? So that's why you have to remember to square the radius. Again, I left it as RA by RC times, cancel the pi, cancel that, right? And 1 by 2. And when you square 1.25, that's what you get, 1.5625 divided by 1. Right? That's where I left it because, like I said, I was too lazy to look at the numbers of RA and RC.
So that's 1.5625.
What is rho A, I mean?
It is 2.65 times 10 to the negative 8.
2.65 times 10 to the negative 8 divided by, and for copper?
1.68 times 10 to the negative 8.
1.68 times 10 to the negative 8. And so now I can cancel these two, right? and times, should not miss the 2 here, 1.5625. And you put in your calculator, what do you get? Top is 4.141. Yeah. Yeah, divide by 2. And the answer is 1.232. So the answer is 1.232. And what's the unit? Of course there's no unit, it's a ratio.
It's a ratio.
Isn't it a ratio? What? No. 1.23.
I got 1.235. Extremely close.
Power is V squared divided by resistance. And so rearrange and you get resistance as V squared by P. The voltage is 240 divided by 75. Remember that in this case the resistance of the bulb is a constant. The resistance is a constant. So I found the resistance. And so in the US, the power produced would be V squared by R. Voltage is 120. Square that divided by 768. Easy question. You should get the power much less, 18.75 watts. So if you want to find the ratio, you know it's 1/4 of the actual power, isn't it? Because remember that you could have done this in your mind, because when the voltage becomes half, the power becomes 1/4. Right? You just can think about it, because the resistance is a constant. Simple question. Okay. And how many have finished number 5?
More like the last.
Okay, I'll wait. I thought I slowed it down a little bit, the playback speed. So power is work over time, which is energy over time, isn't it? Yeah, power is work over time. So energy is power multiplied by time. And power is voltage times current, isn't it? Now why am I doing that? Because I know I times T is what's given, ampere hour. So I said 12 volts times 85 times 3600. 1 hour is 3600 seconds, isn't it? There you go. Your answer, big, 3.672 times 10 to the 6 joule.
Is that 12 times 85 times divided by?
Yeah, it's 12 times 85 times. The power is given as 620 kilowatts, which of course you have to change into watts, isn't it? Probably I'll do that later. And the voltage is 12,000. So we calculate the current first. The resistance is given. Power is voltage times current, isn't it? So you calculate the current. Current is power divided by voltage. Just rearrange. I called it I1, P1, and V1, and you get 620 times 10 to the 3, or 620,000 divided by 12,000. So that current is 51.67 ampere. That's a huge current. That's why it's going to lead to this much wastage. Power wasted. Power wasted is I squared R, like I told you, 51.67 square it times the resistance, which is 3. Which gives you 8,009 joules approximately. 8,009 joules wasted. Okay, but in the second case, if we were to send it at that higher voltage, the current would be 620,000 divided by what? 50,000, isn't it? So 620,000 divided by 50,000, you get 620 divided by 50, which is 12.4 ampere. Much smaller current, as you can see. And therefore, the power wasted would be 12.4, square that, multiplied by the resistance, which is a constant. And you end up with 461.3 watts. Look at the difference. 8,009 watts, and here it's 461.3.
Wow.
That's your problem. Right there.
So it's just to figure out which one wasted more.
In number 7, you have to use this formula. I is equal to NAVE. I've not used VD. VE. And resistance is, see, I realized that we could do that first and then come to this. That's why I just erased that, okay? You saw me erase it. R is B by I. 22 times, what is that? 10 to the negative 3 divided by 750 times 10 to the negative 3, of course. Yeah. And so when you divide, you get 11 by 3, 375, which is, I don't know what, but it's okay. I just left it that way. And then go on to resistivity is R times A divided by length, isn't it? Plug in the numbers. 11 by 375, and the area of cross section is pi R squared. Pi times. Remember that what's given is diameter, so you've got to take half of that. So that's 1 millimeter, which is 10 to the negative 3 squared, divided by 5.8 meter. And then you get it as 1.589 times 10 to the negative 8 ohm meter.
Silver.
Silver? Okay, yes. Now, to find the number of free electrons, that's when you use NAVE. Rearrange to get N is equal to I divided by A times drift velocity times the charge. Plug in the numbers. And as you can see, I'm running short of space, so so pi into the same thing again, pi R squared times this. And since I didn't have the space there, I decided to put the charge of the electron on the other side. 1.6 e to the negative 19, which is the same, right? I'll try to adjust. And you got 8.776 times 10 to the 28. Free electrons in 1 meter cube. Anybody got that? Great. Okay, question 8. First of all, the internal resistance is shown to be in series with the battery. It's going to be in series with it, right? It's its own resistance. So what you see as small r is not a resistance that's connected. It's just the internal resistance of the battery shown along with it. And what you see as caps R is the load. In this case, the starter. And there are two ways of picturing resistances, and I've used both in this case. You see that? It could be a rectangular box, or it could be that squiggly figure like that. So, and you know that the total resistance would be R plus R, right? Because it's in series, correct? And therefore the current would be E divided by R plus R. Okay, I just want to pause here and ask you one thing. If you measure the voltage, and be careful, this is the dangerous thing that I was talking about. If you measure the voltage across the external resistance, will you get the same as when you measure across the terminals of the battery? And you got to think a lot before you answer that. Let me put that question again. If you measure the voltage across the resistance, like I've shown, V volts, will it be the same as when you measure the voltage across the terminals of the battery?
No.
And the simple answer is yes. I know. See, that's why it's dangerous. Hold on. Because if you look at this figure, this terminal and this one, are you watching? Don't miss that, is exactly the same as this and this. Because what's between the two is just a connecting wire. And connection wires have no resistance. That makes sense? So, the 2 points that I touched, which if I want to touch, I have to erase again. This point, the terminal, is exactly the same as this point. I hope somebody understood. Did you? It's the same, because what's between them is the connection wire. Same thing applies to the other side. So if you measure the voltage across the load, in this case, you will get exactly the voltage across the terminals of the battery. That makes sense?
And then we're just assuming that the wires don't have any resistance.
Wires actually practically have zero resistance.
It's just such a
They're like
small.
really small. Doesn't play a part at all. Okay. So now I'm saying the voltage is I times R. That's Ohm's law. So I'm getting the voltage across the external resistance, right? Which is the same as across the terminal. And it's given as 8.4 in that question, isn't it? So that's 8.4 is equal to 12 divided by R plus R. And then I said, okay, we could do it in a much easier way. Because what's the voltage given as 8.4? Is equal to, isn't the current given? I just noticed that the current is given. So you can even see what the current is 75 times R, so you can get the R directly. Yeah, the current is given as 75. Yeah, I noticed it after I wrote that whole thing, so I had to. So you get the resistance as 0.112 ohm.
And that's the resistance at which
Of the
spot?
internal battery.
That's the,
internal?
no, that's not the
That-
internal.
That's the starter, right?
That's the starter
Yeah,
resistance.
okay.
Now, can you please go back to the first equation that I gave you and find out the internal resistance? Surely. I is equal to E by R plus R? Sure, you should be able to.
And then the E is the 12, right?
Yeah, E is the 12. So the current is 75. The E is 12 divided by the resistance which you got as 0.112. And you're looking for the internal resistance. So 0.112 plus R would give you 12 divided by 75, which is, how much did you get for that? 12 divided by 75. 0.16. Okay. So that's 0.16. And therefore, all you got to do is internal resistance is equal to 0.16 take away 0.112. Correct? 0.048. Okay. Now you also notice that the internal resistance is deliberately kept small. It has to be small. Otherwise the voltage drop will be huge and that will be a useless battery. All right, number 9. The resistance of one bulb you have to find first, obviously. And you can use this formula, V squared by P, and find the resistance of the bulb, which is 12 squared divided by the power, which is 3. So you get 48 ohms. Now there are two bulbs connected in parallel, right? So I told you the shortcut is just to divide it by 2. Therefore 48 divided by 2 gives you 24 ohms. So that's the total resistance of both connected in parallel. And then you use voltage is equal to I times R. And remember that the current is actually E divided by R plus R. Remember that from the past. So I plug everything in. So in place of I, you have that, and then R. So the terminal voltage is 11.8 is equal to the maximum is 12 divided by external resistance is 24 plus we're trying to find the internal resistance times 24. Now it's just math, isn't it? Just math. What I did is I switched this to this left side, and so that will become 12 divided by 11.8. So 12 divided by I forgot. 12 times 24, of course, divided by 11.8.
The other R, because he's replacing everything. No,
You can do this in 2 steps. I tried to do it in 1. So you get 24 plus R is equal to 24 times.
so he used the same equation, but he just went.
I mean 24.41 is what I got for 12 times 24 by 11.8. And so R is 24.41, take away 24, which is 0.41. Anybody got that answer? How much?
0.406.
That's fine. Why is that? Where did that approximation happen? I don't.